Okay, so I'm basically looking at the New York dataset, like which is the taxi trip analysis. That's I'm trying to do the analytics and insights into that. I'm trying to do storytelling. Initially, I'm installing these packages since these are not pre-built functions packages. So I had to install these two things, and GeoPanda is basically used in order to access the shape files, which is the latitude and longitude files, and also like Habersan's package is basically used to compute the distances, the geographical distances, because assuming that the sphere Earth is in a sphere, so we need to use Habersan, so it could basically compute the distance. And I'm basically importing the packages, the basic packages which is necessary in order to compute the to perform this or to analyze this data. And secondly, what I'm trying to do is over here is I'm instantiating or creating a sessions by using the Bodo. So what I can do is I will have these SDKs installed on my local PC. So these Amazon Web Services, I will be able to instantiate or create S3 buckets or any Amazon EC2 instance or any other AWS services by using this Bodo. So which means I'll be able to do programmatically, I'll be able to create them. So in here I'm creating an S3 buckets which is inside the region of AP Southeast 2, which is like a Sydney region. And then what I'm trying to do over here is I'm creating a function which basically what it basically does. So sorry, it's not creating a function. What I'm trying to do is, if the bucket is already created, I will not have to create or recreate the bucket. Okay, so I can basically skip it, assuming that it's already been created. And secondly, I'm creating a function over here, so to extract the data sets from the CloudFront, so which is over here. As you could see, these are the packet files which I have to, it resides in a CloudFront. So I'm downloading these files into my S3 buckets, or I'm basically placing them into the S3 bucket. Okay, under a subfolder called data set up here, and that's what's happening here. And also I'm like extracting the dictionaries, as in like, okay, the information about like, okay, what exactly the data set is telling, or what it's the information about the data sets. Okay, so as I could say, and so that's basically my S3 bucket, so which is over here. So as you could go inside over here, I'll be able to see, so like there are some things I've been doing over in the later stages of the code. I'll explain it to you that. So if you go inside here, I'm able to see the data set which I had downloaded into this S3 bucket. And also this is basically the dictionary, so which basically gives you the informations of that. And then I'm basically placing the cleansed data as well in a CSV format, and also all these basically the three data sets combined together, which is like January, March and June. So all three those to combine together, I'm writing in the CSV format. So if anyone wants to use it, they can basically use the CSV, so they don't have to do these packet transformations and stuff. So that is shape files, which is basically used to extract the latitudes and longitudes. Okay, so keep moving. So what I'm trying to do is over here is pretty much that's what I'm trying to do. So I'm basically like trying to place the January data sets and June and March data sets. Okay, so loading and exploring. So I'm basically loading all three datas, and I'm combining them, merging together, so that I can basically do, okay, so I can do some comparisons. So as I keep going down over here, as I could see that the trip volumes, I could see that basically March has got roughly about 3.4 mil, and followed by the June and then the January, as I could see from this plot clearly. And again, if I look at the average durations across the months and the median duration across the months, I could see the June has got high. So because the average and median will not be the same, because it could be biased, or as in like it could be skewed left or right. So that's the only reason why I'm trying to do the average and the median. And again, since based on here itself, I can see since the duration is high, so which means obviously there's going to be a trip, the cost total amount is going to be higher in June, same as that applies to the median as well. So that's why I'm able to see these three. So these are like so these three plots is like explanation or insights, or like how exactly the January, March and June is basically varying. And once I keep moving, so I'm basically trying to do the data cleansing. So all the data are like uncleansed. So I'm trying to target the categorical variables by imputation method. So which means like as in the most frequently used category in that particular column is basically used, or which has been replaced the null values. And then there was two methods I was handled for numerical data. One is the KNN, but due to the resource constraints, I'm not using KNN. I'm basically dropping the gross records, since it's only like as I keep going down here, so I'll be able to see it's like around like roughly 2% or something overall data. So it's not that significant up here, so it's not overall, it's not significant. That's the only reason like I'm trying to drop them. And then once I drop them, I'm placing the cleanse data into the S3 buckets in a CSV format. Okay, so once I keep going down, so identifying the columns, so as I could see, there are like passenger counts, zeros and negative values. I'm removing all the negative values from the numerical data because in the data set up here trip, so because there can't be a passenger count of zeros, okay, because a trip cannot occur with no passengers, and again the total amounts cannot be zeros or basically cannot be negative values as well. So hence like more data cleansing is being done here. So I'm basically dropping them, and as I drop them, I can basically see after effect as well. So I can see like passenger count, I'm like drop it, so that there's not much there, and trip distance also not much there, for amount is not much, and also I can see the total amount. Okay, and also date time, there was some inconsistencies above, so 3, so I'm dropping them, so there's no inconsistency. So it's now it's pretty much like I'm having a data cleanse data, and then identifying the columns that are highly correlated. Because of these are the highly correlated, that's because like if the total amount is going to be higher, so the fair amount is obviously going to be higher, so it's like sort of highly correlated. But if I'm going to looking into a form of predictive models and stuff, I probably will not be using it because it's multi-collinearity, because that one is basically purely dependent upon the fair amount, because as it says, a total amount is basically fair amount, total amount, surcharges and etc. So that's why I probably will not be using this. If I'm going to be using a predictive model, I probably will not be using this. I probably will be considering some sort of like, okay, trip distance against a total amount or something. Okay, in terms of featureization, I'm creating new features like rush hour flag and rush hour flag, the first one. So I'm assuming that the rush hours between 7 to 10 a.m. During weekdays, and evenings like, okay, 4 to 8 and 5 to 10, okay, 4 p.m. to 8 p.m. So I'm not too sure why I basically wrote both the cases. I'll delete that. Okay, so I'll basically could delete that. Okay, so because it's 4 to 8, that's the only thing I'm basically considering over there, so I just can delete that, sorry. Okay, so that's 10 a.m. to 1 p.m. and then 6 p.m. to 9 p.m. because like, you know, like they can go for clubbings or like for a drink, so that could happen, and during the daytime they basically tourists can go somewhere. So I'll just assume that under assumptions I'm basically making these things so that I can compute my rush hours, because I did not use that extra column which has got 0.50, like as if 50 cents is being charged, but they can be misleading as well, because like they probably not would have entered the correct data. So that's the only reason I'm not doing that. So then I'm creating the rush hours. As you could see how much I'm creating, this looks like a reasonable amount. And then what I'm trying to do is I'm utilizing the shapefile, so I'm able to see extract the latitude and the longitudes, and I'm basically able to compute the distance. Okay, so as you could see, the trip distance and have a sign distance and trip complexity. So what I'm trying to do is like the complexity, when the complexity is closer to 1, means the ride was almost a straight line, while a higher complexity value means the ride took a more complicated route, right? So this might help us understand the traffic patterns and efficiency of each ride, and whether certain areas tend to move more straightforward or complicated paths. Okay, and then pick up and drop off times, I'm able to see for each location's IDs, I'm able to compute them. And also data analysis, so I'm doing some sort of data analysis like up here, like so vendor IDs, who basically which vendors are basically used more, like as in which taxi, like, you know, like different taxis up there, so which vendors. Okay, and then peak travel hours, I'm computing, as you could see from here, like the peak times clearly can see like at 5 o'clock and 6 o'clock you can see there. And also if I look at the percentage, it's like more, it's like middle, there's none. So morning and evening times, like there's more sort of like, okay, peak hours are picking up. So that's what I'm been mentioning it up here. And then if I keep going down, I can see the trip distances. I can see like on weekend, okay, so it's sort of like, okay, I'm computing more in weekends than the weekdays, looks like that. So under my assumptions earlier, so I was thinking about like, okay, the tourist sites can be happening, so that's the only reason I've been doing over there. And then the average number of passengers in terms of like trip on weekdays and weekends, so I could see more people are going out, seems to be going out on a weekend. weekend. Okay, and then in terms of correlations between a fair amount of tip and a fair amount of number of passengers, as you could see, this is more like highly correlated or moderately highly correlated. This is like not at all correlated, so it's like very weak positive correlation, but both are positive correlations. Okay, so that's what I can basically say in terms of them. So in conclusions, what I'm trying to say is basically our analysis paints like a vivid picture of a taxi usage in the city, helping us to understand where, when and where the taxis are most in demand, and how much people usually pay, and how they tip the drivers. So this information can be essential for taxi companies to improve their services, optimize their operations, and meet their customer needs more effectively. And so some sort of reflective analysis which I've been doing up here. So that's like my reflect towards like what exactly is happening, reflect on any challenges I faced during the analysis, and then suggestions that I could happen, like I can basically model a driver analysis, or I can do a temporal analysis. Okay, so predictive modeling. Yeah, so that's it. So I basically will be sharing this on GitHub. I'll just provide the link down on the YouTube. Yeah, thanks guys. Thank you for watching, and I'll explain in another session how I basically created the S3 buckets and how I installed the SDKs in another YouTube channel. Okay, on a YouTube link. Okay, thank you guys.